Hello everyone, welcome to day 2 of our data science journey. As I mentioned in last class, today we'll begin exploring probability and statistics. Before diving into today's agenda, let's have a quick look at course curriculum of this section. It's all about 23 sessions. I want to cover each and every topic that are required for data science. I'll cover probability and all distributions, descriptive statistics, inferential statistics, all the tests that are required for inferential statistics. I'll cover all the tests. I know I should start from SQL, but you all know they are all common topics with a lot of videos on YouTube. You can learn from YouTube. If I get free time, I'll make videos on those topics too. I'll cover Python, Pandas, NumPy when I get free time. As of now, I want to cover more math part, machine learning and all that. Let me write down agenda for today's discussion. As you expect, we cover a lot of concepts. In today's discussion, we'll cover a lot of theoretical concepts rather than practical. In fact, I'll bring in some real world examples to show you how probability is applied in practice so that you can connect all the dots. In the future, you need to understand probability. There is something called set theory. In the future, I'll start this set theory maybe in next session. We gradually goes towards probability. I'll relate the concepts of set theory to the probability whenever it's required. Let me write down some basic terminologies. Here we discuss sample space and outcomes and events. In events, we discuss joint events, independent events. We'll discuss all this. When you apply for jobs, every company asks certain skills for each role, right? Let's look at some of the skills asked by few companies for a data scientist role. Let me zoom it. Here you see these skills are asked by Tech Mahindra for data scientist role, and here you see they asked probability theory, probability distributions, and hypothesis testing. Sometimes you might see something called descriptive statistics. It's also important. Let me show you few more examples. Here you see this is same skills asked by Kmart for data scientist role. You see the probability, statistical distributions, inferential statistics. Inferential statistics is an alternative name for hypothesis testing. Let me quickly explain what is inferential statistics with a simple example. Let's imagine that you don't have marks of a whole class. You have only marks of 10 to 15 students. Based on that small sample data, you are trying to estimate the average marks of a whole class. This is called inferential statistics. With a small data, small sample data, you are estimating the whole group. You got my point? That's inferential statistics. When you go deeper into inferential statistics, you understand very clearly what it is. As of now, just keep this overview in your mind. And here for Microsoft also they asked same skills. See, probability, statistics, A/B testing. A/B testing is the one of the tests in the inferential statistics in a hypothesis testing. I would like to give you a real-time example to show you how probability is applied in real world, how probability play a role in real world. For that, let me open Amazon. What do you observe on screen? I'll give you 10 seconds. Just mention on a piece of paper what you observe on screen. Okay. You might have observed the image of this face wash, the price, discount. Anyone of you observed this add to cart and buy button? Why do you think they put orange to buy now and yellow to add to cart? On what basis they did that? Is there any logic behind that? Or just out of the blue? Or a random person simply woke up and felt orange seems well for buy now and yellow seems well for add to cart? They put those colors based on color psychology, and this color psychology, is not a gimmick. It's a well tested experimental result that led buy button to have orange and add to cart have yellow. Let's say you are working as a data scientist and you are working with this UI and UX designer. You know what is UI and UX, right? Here, UI stands for user interface and UX stands for user experience. And their job is to design websites and to take care of how this interface look and how users are interact with it. This is their job. Now, this UX engineer has to take decision on what color should be used for these buttons, what color should be used for add to cart and what color for buy button. To decide this UI UX designer reach out the data science team. Now this data science team is then responsible for conducting an experiment to determine what colors what colors should be used for these buttons. Whatever you see on this interface, like in Amazon web page, the image placement, price, discount is all are outcomes of this well defined experiment. This experiment is based on real data and user behavior. It's right here. Add to cart and buy. Let's answer the question how they decided. Here, my main goal is to tell you how probability is used in the background of things. If I bring question of what color should be used for these buttons into some mathematical equation, isn't that more practical, which is unbiased? That's the end goal, right? It's completely subjective. It's completely on the data, right? These data scientists may do A/B testing. They take two groups. Let's call it group 1. Let's say it as group 2. Each group has 5,000 people. We look into A/B testing more clearly in some form when we discussing hypothesis testing in the future classes. For now, just understand this, okay? Before looking into this, just tell me what is the purpose of Amazon website? What is the purpose of having this best data scientists and the UI UX designers? All of these roles works together to help Amazon grow, right? To improve sales, ultimately generate more revenue, right? Hold this idea. For now, we present a different version of web page to each group. Let's say we call it UI1. We show this to we show this UI U1 web page to group 1 people. Okay. Here add to cart is, let's say it's black, and buy button is blue. This is shown to group 1 people. Out of 5,000 people, let's say only 3,000 people click on buy button. Ultimately, we have to only look at a buy button. So because our end goal is to improve the sales, right? When add to cart is black and buy button is blue, 3,000 people are interested to make a purchase. Okay. Now for group 2, we show a different version of web page. Let's call it UI2. Here add to cart yellow and buy button is orange. This group also include 5,000 people, right? Let's say in this 5,000 people, 4,000 people interested to make purchase and the rest they don't have interest to make purchase. Only 4,000 people clicked on buy button. Okay. Isn't it shows how color choices in a UI UX design influence the user behavior and improve the sales? We'll write it mathematically. Okay. This fraction is something called probability. When you solve this, you get 0.6. You get 0.8. What does mean this 0.6 and 0.8? This 0.8 says that there is 80% of chance the people would make purchase when buy button is orange and add to cart is yellow. There is 80% probability, it says. Here it says there is 60% probability or chance people make purchase when add to cart is black and buy button is blue. Are you able to understand this fraction? Here it says out of 5,000, 3,000 people clicked buy button. Here 4,000 people clicked on buy button. When you solve, you get 0.6, and when you solve this, you get 0.8. It says there is 0.6 probability and 0.8 probability here. And do you understand how 0.6 is converted to 60% and this 0.8 is converted to 80%? In order to understand this, do you know how to solve this percentages and discounts? In order to understand that, you need to understand multiplications first. What is the meaning of 2 into 2? Don't say it as 4. Just think about intuition behind this. This is nothing but 2 plus 2, right? What is multiplication? You're adding 2 with another 2. That's called 2 into 2. If it is 2 into 3, you're adding 2 3 times, right? Let's focus on this. You'll get the idea why we call 0.6 as 60%. You understand this, right? Then say this. It's 0, right? What does it mean? You're adding 0 2 times, right? Nothing plus nothing, it's nothing, right? Few months back, I watched a reel on Instagram. This video was about a child. The child was confused about some basic maths, and his question is, why does something is multiplied with 0 always gives 0? And he had logic also. His logic is, if the person with nothing is multiplied with the person with something, how it would be 0? How it would be nothing? The logic is simple. He even asked the teachers, they are not able to explain him clearly. And he, at some point of time, he thought there was no answer for that. Logic is simple here. It's not about multiplied with the person had something. Here, if 0 into 2 means a person with nothing, there are some other persons with nothing. Like if you two persons, the same similar two persons had nothing. When they added together, what they have? Nothing, right? There's a simple idea behind that. Here also, you see, 0 into 2. We're adding 0 two times. It's become 0. Nothing plus nothing equals to nothing. Now, answer this. What does it mean? 0.5, right? How? How you add like this number? Here you have to understand one thing. If you see this 2 into 1 equals to 2, right? 2 into 2 is 4, right? What this 1 and 2? Isn't it saying when it's a 100% of 2 is 2, right? Isn't it saying when 2 into 2, it means we're adding 2 two times, right? What does mean? This, if it is 100%, what it's become? 200%, right? What is the 200% of 2? 4. If it is, what is 300% of 6, right? This is 100% of 2. If it is, this is another 100%. If you add all these percentages, isn't it 300%? Apply the same idea here. Here you are looking for what is the 0.25% of 2. Let's see. This 0.25 plus 0.25 plus 0.25 plus 0.25. If you add this, it will be 1, right? 1 means what? It's 100%, right? Now, this is 25%. This is all 25%, right? Become 100%. Then what is the 25% of 2? 0.5, right? Plus 0.5 plus 0.5 plus 0.5. If you add this, if it is if you add all this 25%, it becomes 100%. What is the 100% of 2? 2, right? See, what is 100% of 2? 2. Yeah, 2. Then what is the 0.2% of 2? 0.5. Now, are you able to relate this to 0.6 probability? How is it 60%? Here 0.25 is 25% probability. We'll look at one has 100%. If it is 0.75 is 75%. Is it clear? Now are you able to connect all the dots? Is it so simple? In probability, we consider one has 100% and 0.2 as 25%. Don't get confused. Don't overload your brains. Some of you might thinking he said when we multiply two numbers, if we multiply 2 with 1, we have to consider 1 as 100% and the result is 2. But when we divide two numbers, how does the result represent the percentage? I know that's your doubt, right? Like 3000 by 5000, 0.6. How this 0.6 is the percentage? Before I said it's 2 into 1 is 2, this is 100%, and 2 into 0.25 is 0.5. Earlier I said this, right? But when we divide two numbers, how does this value represent the percentage, right? Don't worry, we'll go deep into the concepts and I explain you very clearly. Now, I'll explain this with discount problems. Isn't it okay for you? Understand the things very carefully because the first class is very important. In the future classes, you see this percentages and decimals. When you see those numbers, you'll get confused. Okay. I'll clear up your all your doubts using the discount problem. Okay. When we go shopping, we often see discounts in stores, right? Like 25% off, 50% off. How do you calculate that? Let's say actual price is 200 and the discount is 25%. How do you calculate this? You simply convert this 25% into decimal and you multiply with 200. What is it? 200 into it's 50 rupees, right? 50 rupees is your discount. What did you do here? You're finding portion of 25% in the whole 200. That's 50 rupees. Is it clear? For suppose the store doesn't give discount in percentage, it gives in rupees. Like it says your discount is 50 rupees and your bill is 200. And your mother asked, what is the discount in percentages? And now you have to tell her in percentage on your total bill. How do you do that? If, if it is, you find out it says 50. If you send to right side, isn't it 0.25? What is this? 25%? Got my point? Just sending it to right side and you get this. When you divide discount by actual price, you'll get discount in percentage. How division works here? Do you understand? When you divide 50 by 200, how it's 0.25? What's happening here? Do you understand? Let me explain. Let's see what is division. Can you solve this? What do you get if you solve this? How do you solve this? Simply you say 10 ones are 10 tens. What does this 10 mean? Isn't it 1000%? Here you are comparing 10 with 100 and you are saying how many times 10 fit into 100. You're saying times. You are saying 10 times. One time equals to 100%. 10 times equals to 1000. We saw this in multiplication, right? 10 into 10, it's 100, right? 1000%, right? We're just simply saying there are total 10 tens, becomes 100, total 10. Each we consider it as 100%, total 1000%. I think you understood this. Now, this. If you solve, what do you get? What is this? 10%, right? What did you do here? You just simply reverse the fraction, right? What happens if you reverse? Now you're comparing this 100 with 10. That's it, right? That's 10%. You're saying what percentage 100 is of 10? 37%. We call it as A. And this person's height is 100 inches. And there is one person B, the small person. His height is 10 inches. And this person height is 100 inches. Okay, now compare this small person with this tall person. How many times this A person is taller than this B person? I'm saying how many times? This is 100, this is 10. How do you solve this? Just say 10. You get 10 times, right? Here you are comparing the small person with this tall person, right? How many times is taller than small person? It's 10 times. Which means 1000%. If we get value 1, it means 100%. But here, what value did we get? 10. It means 1000%. Right? Now, what does this mean? You just reverse the fraction. You are now asking question in reverse. Now you are looking from the small person point of view, and now the small person is comparing with this tall person. This now the small person asks what percentage is my height compared to this tall person's height. How much percentage it is? What is the height of the small person? 10, right? Isn't it 10%? If height of this person is 100, right? Here also it's 10%. Now are you able to understand this? It's so simple, right? Now we'll go back to our problem. What is happening here? See, here the person height is 200, and there is another person whose height is 50. Now he's comparing his height with this person's height. This person is asking what percentage is my height compared to this person's height. That's it, right? What do you get? 0.25. That's it. What's happening here? Here, the small person's height in percentage compared to this tall person height. What is it? It's 25%. What is the 25 percentage in his height? That is 50. It's so simple, right? Now are you able to connect all these dots? It's so simple, right? Now, let's go back to our main problem. Do you remember what is our main problem? Yeah, here it is. Now, are you able to understand this calculation? Why we call zero point 0.6 as 60%? See here, what I'm saying here. Here I'm asking what percentage 300 is of 500. I'm saying it's 60%, 0 0.6. Simple. What is 5,000 into 0 0.6? Isn't it 3,000? The same. What is this? Is this 60%? That's it. It's so simple. Now are you able to connect all the dots? And in probability, why we consider one as 100%? Do you understand how simple it is now? Do you like my explanation? For most of the people, my explanation seems basic or even silly for people like who already understood these concepts. But I see most of the people they know how to solve, how to do math, but they can't understand the reason behind it. Ultimately, my main goal is to make learning accessible for everyone. So if anyone feel like it's silly or basic, please feel free to skip or just bear with us for a few minutes. Yeah. Can we write this fraction more intuitive manner or a readable manner? In mathematics, how do you represent probability? We represent probability with a capital P, and this P is coming from probability term. Let's write it for probability of clicking on buy button on UI2. Writing it mathematically, we start with P, then we'll keep brackets. Inside these brackets, we'll keep our condition. What is our condition here? Clicking on buy button on UI2. What is the value of this probability? Isn't it 4,000 by 5,000? Is this value it's greater than probability of clicking on buy button on UI1? Now everything is clear. This is how data scientists and UI UX designers come up with this idea. Yeah, now we have to go with this. What is this? UI2. Now they decided to go with UI2. You understood? In intuitive manner, I explained what is A/B testing, right? You'll see it more depth in hypothesis testing and a full-blown manner in a product analysis model. Yeah, and who are looking for actual definition of probability, I'll add that in today's notes. From there, you can read it and you are able to connect it with a concept I explained during the session. Now, our next topic is basic terminologies. In this, we see what is experiment, sample space, outcomes, and events. We'll see what these terms are, and let's start with what is experiment. Experiment is nothing but performing some activity, right? Let's say you have some mathematical equation that you want to solve. Let's say it as a square plus b square plus 2ab. And to solve this, we keep a equals to 3 and b equals to 4. Okay. My question is, if we solve this question, how many different values will get out of this equation? Let's solve this. Just plug and play. 3 square plus 4 square plus 2 into 3 into 4. What is the value? Won't we get 49? We'll get only single value, right? Somebody comes and says, no, sir, I get three different values. One is 39, 69, 79. Is this true? No, right? We only get one value. The output we are getting out of this equation is determined, right? These kind of experiments are called as deterministic experiments. You got my point? I'll explain you more clearly. What is function? Here our function is a square plus b square plus 2ab, right? You are passing inputs a and b, right? And output we are getting is 49, right? It's 3 and 4. If you solve this equation, or if you repeat solving this equation, like if you try to solve it for 100 times, this value change? No, right? You'll get same value for all 100 times, right? This output, isn't it deterministic? So these kind of experiments are called as deterministic experiments. What are the non-deterministic experiments? Call them as probabilistic experiments. Under these, rolling a die, tossing a coin, what else? Picking a ball out of box. This all are comes under probabilistic experiments. Outcomes of these experiments are non-deterministic. We don't have single outcome. We'll have like 1, 2, 3, 4, 5, 6. It could be anything, right? The output would be, would you say if you roll a dial, you only get one? You roll a fair die. If you toss a fair coin, you get only heads? No, right? Your output would be, it would be either heads or tail, right? So these kind of experiments are non-deterministic. You understood? Let's see example. Rolling a die. Here experiment is rolling a six-sided die. We want to observe the all possible outcomes of this experiment. If you roll a die, one, these all are possible outcomes of this experiment. Okay, you may get two, three in a single try, four, five, six. Right? Is this point clear? Okay. In a single trial, you may see one or two or three or four or five or six collection of all possible outcome of this experiment is called sample space. So one, two, three, six. We denote it with capital S. This is the all possible outcomes of experiment. This is the sample space for this experiment. You understood what is sample space now? Let's imagine we are rolling two dice simultaneously. Let's keep it as example 2. Okay, rolling two dice at same time simultaneously means so one die and this is another die. Imagine what are the possible outcomes for single die? Isn't it one, two, three, four, five, 6, and here also it's same, right? What are the possible outcomes for rolling two dice simultaneously? What are the possible outcomes for rolling a two dice? Imagine your friend and you are rolling a die at same time. If you get 2, your friend may get 3, 4, 5, 6, or 2, 2, like that. It goes, right? These are all possible outcomes for two dice, right? We can write it. It is in a sample space. The collection of all these outcomes are called sample space for this experiment, right? It could be 1, 1, 1, 2, 1, 3. It goes, right? How do you find out number of outcomes for this experiment without counting each and every single outcome? How do you find out total outcomes for this experiment? How many possibilities do we have here? Do we have 6 possibilities from die 1, right? And another 6 possibilities from die 2, right? Do you see this? And what are we doing here? We are multiplying, right? 6 from die 1 and another 6 from die 2. It's total 36 outcomes, right? See this. Here it has 6 outcomes, 6 possible outcomes, right? And here we have another 6 possible outcomes. We're saying and it means it's a multiplications 36. Let me show it to you in a nice tree structure. Okay, for die 1, how many possibilities do you have? Die 1, die 2. How many possibilities do you have? 2, 3, 4, 5, 6. For each outcome in die 1, how many pairs it has with the die 2? 1, 2, 3, 4, 5, 6, isn't it? How many combinations you can make with 2? Another 2, 3, 4, 5, 6, right? Here same, right? 1, 2, 3, 4, and here also same, right? 1, 2, 3, 1, 2, 3, 4. We'll consider this as one outcome, right? Like that, how many you have? Here you have 6, here you have 6, here you have 6, 6, 6. Just add this 6 plus 6 plus 6 plus 6. How many total? It's 36. There are total 36 possibilities. Let's see, tossing a coin and rolling a die at the same time. Coin and tossing, sorry, rolling a die. For coin, how many possibilities are there? 2, right? What is the sample space for this? Tail and head, right? And how many possibilities are there for rolling a die? Isn't it 6? 1, 2, 3, 4, 5, 6. 2 into 6. How many? It's 12. Let's see in tree structure. This had how many possibilities? How many combinations it can make with a die? 1, 2, 3, 4, 5, 6. Here with tail, another 6, right? This is one. This is one outcome. This is one. This is one outcome. This is one outcome. This is one outcome. This how many? 6, 6. 6 plus 6. Isn't it 12? Is this point clear now? Are you able to connect all the dots now? Yeah. Now let's see what is event. This is the last concept for our today's class. I feel tired too. Yeah, here I have some space. What is event? Event is subset of sample space. Let's write it mathematically. You can define it with capital letter E. This is subset of sample space. This is the symbol that represents subset. I'll explain you what is event using our previous experiment, rolling a single die. Or you know what is the sample space for rolling a single die, right? What is the sample space for single die? 1, 2, 3, 4, 5, and 6, right? Now I want to see only even outcomes from the sample space. What are those? 2, 4, and 6, right? Let me write here. What are the odd outcomes? 3, 5, 1, right? These two aren't subset of sample space. These two are called events. Let's write it. Let's call it this as E1 and this is E2. And E1 and E2 are subsets of sample space. Here, every event has some condition. What is the condition for E1? All even outcomes, right? And what is the condition for E2? All odd outcomes, right? Yeah. These E1, E2 are nothing but events. Let's see another example. Here, tossing a coin. What is the sample space for tossing a coin? Heads and tails, right? How do you define events for the sample space? Let's define event 1. Before defining any event, we have to write the condition for it. What is the condition for it? Getting heads when tossing a coin. How many heads are there in sample space? Only one, right? E1 equals to heads. Let's write E2. What what is the condition for E2? Getting tails. I mean tails 1. We can also define event like getting either heads or tails. Let's call it as E3. What is the, yeah, these all are subset of sample space, right? Called events. These are called events. That's it. Oh, yeah. I'll explain you idea of what is sample space, events and experiments using real world data set. Let me open this. Yeah. Before I go into explanations, I want to clear few things. Don't overthink it. What you currently know might be less than 1%, and that is completely fine. If you try to analyze deeply with a limited understanding, your brain will raise many questions, right? That's a good thing, but let it happen. For now, just listen. Things will become clearer in future classes. Don't try to understand the whole data set with whatever knowledge you got with this class. Just think that this whole data is sample space, and each column is an experiment. This all experiments are done simultaneously, and when you try to filter out the data or like while keeping some thresholds, like let's say you want to filter out the people who are depressed and whose income is less than 50,000. This is the one condition, right? When you pull out all the data who income is below 50,000 depressed, those data is an event. Am I right? Yeah, that is event, sample, and experiment. Just think like this. But this is not the actual truth. Whatever we discussed in today's class is a theoretical theory. There is something called empirical theory. When you go into that, you'll understand the some idea of this data set. For now, just understand whole data is a sample space and rows, columns, or experiments, and the filtering is called events. That's it. Thank you.